Hi, my name is Michael Marquez. I'm a senior software engineer here at CircleCI. I'm excited to announce CircleCI Server 3.1. In this video, we're going to discuss three of the latest features: server metrics, backup and restore, and finally runners. Let's get started. First feature we're going to discuss is server metrics. Server metrics allow you to view various metrics sent by each of the services used to run the CircleCI application. For Server 3.1, we added the ability to add a high-level metrics overview to the COTS admin console. Additionally, we added support for exporting server metrics data using the open source project Telegraph. Here's a quick demonstration. Here we are in the configuration portion of the COTS admin console. You can see the newly added Prometheus server section. You can enable this to feed the high-level metrics overview in the application dashboard. Once enabled, we then simply add the Prometheus endpoint here. And you can see the high-level resource usage from each of the services. If you have your own metrics collection service running and wish to relay metrics to it, you can customize Telegraph here. Telegraph offers many output providers to help you. A link to their documentation is provided. For this demo, I've configured Telegraph's Datadog provider to send metrics to a demo Datadog account. You can see that I've already run some builds and that the metrics are being sent to Datadog. Please check the documentation for more details on server metrics. Next, let's discuss backup and restore. Backup and restore feature has been integrated with the COTS administrative console. It uses the popular open source project Velero, which allows you to quickly back up your server installation to an object storage provider such as AWS S3, Google Cloud Storage, or to an object storage service hosted on your own infrastructure. You can easily make this a part of your organization's disaster recovery plans utilizing scheduled backups. Additionally, you can quickly take snapshots prior to common events such as system updates. Let's take a look at a quick demo. In this demo, I plan on providing you with an overview of the newly added snapshots page in the COTS admin console. We will also take a backup of an existing Server 3 install. Lastly, I will simulate a failure and demonstrate how to perform a system recovery. In the interest of saving time, Velero has already been installed and configured in our cluster. To get started, I'm logged into the COTS admin console. Let's visit the newly added Snapshots tab here at the top of the page. Here we can see that we have two types of backups available to us: full snapshots and partial snapshots. Partial snapshots only back up application volumes and application manifests. They do not back up the admin console or the metadata about an application. You may want to perform a partial snapshot before performing a system upgrade. Full snapshots not only back up application data, but they also capture the admin console data as well. This is the snapshot type that will be used for disaster recovery. Lastly, the Settings and Schedule tab allows you to review your object storage settings and schedule backups. You can easily schedule backups by selecting the tab corresponding to the type of snapshot you would like to take. You can then check Enable Automatic Snapshots and select the backup cadence. Finally, set a snapshot retention policy which helps you reclaim space by automatically deleting older snapshots. Now let's perform a backup. Here you can see that I have an existing Server 3 install running. You can see the pipelines page already has a few builds that have been run. We can easily perform a backup by going to the admin console and selecting full snapshots. Now we select the Start a Snapshot button. A backup is now in progress. This will take a few moments, so I'll pause and return when the backup is complete. The backup is now complete. You can see that a new backup instance has been created. Now let's simulate a system failure by deleting the namespace the server install is running in. This will take a minute. I will pause and resume once the deletion has completed. The deletion is completed. First, we can list available backups by running kubectl COTS backup ls. Let's copy the name of the latest backup. Now we can start the restore process by entering kubectl COTS restore from backup and the instance name. We can verify that the restore process is started by checking that the namespace has been created. We can see that the restore process has started. This will take a few moments. I will pause and resume once the process is completed. The restore process has been completed. There are a few additional steps required to complete the restore process. I will take a small break to perform them. However, these steps are outlined in our documentation, so fear not. With the additional steps completed, we can verify that all of the pods have been recreated and are in a running state. Finally, let's visit the server application. We can see that the application has been restored. Backup and restore was a highly requested feature, and we're happy that we're able to bring it to you as part of this release. Now let's discuss another new feature being introduced to Server 3.1, CircleCI runners. CircleCI Server has supported short-lived Linux and Windows-based builds for quite some time. However, there are times where developers need to perform builds in historically unsupported operating systems such as macOS or hardware types such as ARM or GPU. Additionally, there are some datasets that are far too large to be managed by CircleCI artifacts alone. We're happy to announce the addition of CircleCI runners to Server 3.1. Runners will allow you access to unique and long-running environments, giving you full control over how they're managed. Let's take a look at performing a build on one of our most requested build environments, macOS. Before we begin, you should know that CircleCI runners requires that you have CircleCI CLI tool installed. We will provide links to the installation documentation. When setting up the CLI tool, you will need to have the domain of your CircleCI server installation, as well as a personal API token generated from within the server install. This permits the CLI tool to interact with your server instance. Using the CLI, we can now create a namespace for your organization's runner resources. This can be done by running the command CircleCI namespace create, the namespace name, which is server demo in my case, the version control system type, which is GitHub, and lastly an org name, which is my GitHub org Mikey Yaya. Keep in mind that the org name is case sensitive and you're only allowed one namespace per organization. I've already performed this step, so next you will need to create a resource class for a new runner. You can create a new resource class by running the command CircleCI runner resource class create, the namespace name, which we just created in the last step, / the desired resource class name. For this demo, I am using server demo / macOS Big Sur. Finally, you will need to provide a description of the resource class. This is helpful for distinguishing between multiple resource classes within a namespace. I've already performed this step as well. We can verify that the namespace was created by running the command CircleCI runner resource class list and the namespace, which is server demo in my case. Lastly, we will need to create a token for authentication with our newly created resource class. We can do this by running the command CircleCI runner token create, the resource class name, which is server demo / macOS Big Sur in this example, and a nickname for the token. I'm using token for demo. This will generate a new token that is only visible once, so make sure that you save this and don't lose it. Now that we've configured the CLI tool and created a resource class for our runner, you are now ready to install the launch agent on the system you wish to run builds on. I've already gone ahead and performed the step on my local machine running macOS Big Sur. The steps to install the launch agent vary based on the operating system, so you need to refer to our documentation for details on setting up your environment. With the launch agent installed, let's take a look at configuring a build. Here we have a simple CircleCI config.yaml file. In order for this build to target our runner instance, you need to make sure that the machine key is set to true and that the resource class is set to the resource class that we created earlier. In our case, this is server demo / macOS Big Sur. With that set up, let's push a commit and trigger a new build. We should see a Firefox window open up on my local machine if everything is working correctly. And there we go. This was a very simple demonstration, however, it is easy to see the possibilities that can be unlocked by using runners in Server. Thanks for watching this demo. If you have any questions about Server 3.1 or anything else server related, please be sure to reach out to your customer success manager or visit our docs at circleci.com/docs. Thanks.